Welcome to the presentation of our paper, Stability Analysis of VSC Systems using the 3x3 Admittance Matrix. My name is Ali Al-Jum'a and I'm a PhD student at the Smart Grid Power Systems Lab in the University of South Florida. So the objective of our paper was to conduct a stability analysis of the VSC system using the 3x3 Admittance Matrix model. Our work was actually motivated by that most of the existing studies are based only on impedance models that are viewed either from the AC or DC sides. However, an admittance model was developed to overcome this problem. It's a 3x3 admittance matrix model that can incorporate both AC and DC viewed admittance at the same time. It allows us to model the VSC independent of its AC and DC side network, and it can show the coupling effect between the AC and DC side networks. So for example, the system that our study was conducted on is shown in the bottom here. It's divided into three zones for the purpose of explanation. The 3x3 admittance matrix model to its right represents only zone 1, and it's independent from zone 2 and zone 3, which are the DC side and the AC side networks respectively. So our contribution to the existing work was to show how to obtain this 3x3 admittance matrix model using the time domain step response data of an electromagnetic transient simulation testbed in combination with the eigenvalue realization algorithm toolbox that was developed by the USF SPS lab. Also to demonstrate how to use the Cron reduction on this 3x3 admittance matrix model to examine the effect of the DC or AC side networks on the AC or DC viewed admittance. And finally, to use this model to conduct the eigenvalue-based stability analysis. So to show the effect of the DC side impedance on the admittance viewed from the AC side, the previously modeled 3x3 admittance matrix model was aggregated to include the DC side network dynamics. Then the Cron reduction was used to come up with this 2x2 admittance matrix model that represents the AC viewed admittance in terms of the DC side networks element. And to verify our analysis, we measured the AC viewed admittance with the existence of the DC side network and compared it to the admittance resulted from the conducted analysis here. The two results match pretty well. As we can see here, the blue curve represents the analysis result, and the dashed red curve represents the measurement taken from the EMT testbed. A similar procedure was done to show the effect of the AC side impedance on the admittance viewed from the DC side. Finally, for the purpose of determining the effect of the AC or DC side networks on stability, the eigenvalue analysis is performed. The Y stability here represents the 3x3 admittance matrix model that is aggregated to include both AC and DC side networks element. We can find the eigenvalues of a system by finding the zeros of Y stability here. To validate this approach, we compared the EMT testbed results with the eigenvalue results of Y stability. For example, when we wanted to test the effect of the AC side networks on stability, several experiments were done where the value of the line impedance was incremented in the EMT testbed until the system showed some oscillations as a result of a step change in the BCCC bus voltage. For example, when we reached the value of the line impedance that is 0.959 per unit, the time domain data showed 6 Hz oscillations resulted from the step change in the BCC bus voltage. Similarly, the eigenvalue projectile results of increasing the line impedance from 0.4 to 0.959 per unit showed 6 Hz pulls approaching instability as the value of the line impedance reaches 0.959 per unit, which is the same conclusion as the time domain data results. On the other hand, similar experiments was done to examine the effect of the DC side network elements on the system stability. So to sum up, the identification process of the 3x3 admittance model using the EMT test beds measurements and the ERI toolbox was performed. The model was used to conduct the eigenvalue-based stability analysis, and further research can be conducted in the future to apply this 3x3 admittance matrix model on different VSE based systems and applications. This is the end of the presentation. Thank you for listening.